Just hold on 1 second. चले let's start. कोशिश करते हैं 2 papers कर लें. Let's start with this. Hopefully everyone can hear me. Uh, एक second रुकना. अच्छा, so starting with the first question, why is N2 very unreactive? Now there are 2 reasons for it being unreactive. One is okay, it's a triple bond. It's a strong triple bond. Since it's only 1 mark, so that would be strong triple bond. And the other thing is that it's non-polar as well. So since it's non-polar, it's not going to attract any molecules. Now, magnesium and lithium both form nitrides, and the compounds both contain N3 minus 1 ions. And you're supposed to write an equation for the reaction of magnesium with N2 to form magnesium nitride. So that's easy. That's Mg plus N2. And that gives you Mg is 2 plus N is 3 minus. So it's Mg3N2. And you can balance this. This would be 3 Mg. The next is solid lithium nitride reacts with water. And when it reacts with water, according to the following equation, state one observation that you would make during the reaction. Now, one observation that's clearly visible is that there is a solid and it turns into aqueous. So the solid, it dissolves. Okay, that's one observation. Uh, since NH3 is aqueous, you can't really smell it because it's written in aqueous state. State one industrial importance for ammonia. Ammonia is used as a fertilizer. NPK fertilizers are made mostly from ammonia. Fertilizers that contain nitrogen, phosphorus, and potassium. Next one is one method of producing ammonia is by heating ammonium chloride with CaO. Explain what the reaction produces ammonia. Now, the reason this reaction produces ammonia is that it's an acid-base reaction. What happens is that calcium oxide is going to act as a base. And it acts as a base and accepts H plus 1 ions. To form H2O. And where does it get those H plus 1 ions? NH4 plus 1 acts as the acid. And it donates an H plus 1 ion, which means that it loses the H plus 1 ion to form NH3. So that's what's happening. That calcium oxide is acting as a base. The oxygen in calcium oxide is acting as a base and accepts H plus 1 ions to form H2O and takes away the H plus 1 ions away from NH4 plus 1. Now the next part is the 3 oxides of nitrogen. Complete a table to give the oxidation numbers, so that's easy. This is +2 and this one over here is +4. Okay, so those are your oxidation numbers. Next है कि NO2 can be formed by the different chemical reactions. Write equations for the formation of NO2 by the reaction of N2 with O2. So N2 plus O2 forms NO2. And there's going to be 2 N2 and O2. The next is that the thermal decomposition of magnesium nitrate, so that is MgNO3 twice. It's going to decompose to form MgO, plus it's going to produce 2 molecules of NO2, plus it's going to produce half molecules of oxygen. Okay, remember the decomposition of nitrates, all of them are going to behave exactly the same way. Here you have number 3, which is molecules of N2O can be formed by the reaction between N2 and O2. The bond between the N and O atoms is a coordinate bond. So they've shown the bonding over here. Now the enthalpy change for this reaction is 82. Calculate the bond enthalpy. You have to figure out the bond enthalpy of this bond. Now in this reaction, you're going to use data booklet and you're going to use this formula, which is you're going to try and calculate the energy that is needed for bond breaking. That would be endothermic minus exothermic, the energy that is released during bond formation. So in this question, we already have the answer, that is 82. That the enthalpy of the reaction is given as plus. It's given as plus 82 kilojoules per mole. So what do we need? We need to, how many bonds do we need to break? So we would have to break the N triple bond N, 2 of them. 2 N triple bond N bonds need to be broken. So 2 N triple bond N bonds, they have to be broken. So that's plus. And you would have to break 1 oxygen double bond oxygen as well. And then subtract how many bonds would you form? You're going to form 2 N triple bond N. And you're going to form 2 N and O oxygen bonds. These coordinate bonds. They are the ones that need to be formed as well. Now, if you look at the equation, 2 things are going to get cancelled out immediately, and those 2 things are the N triple bond N would get cancelled out. So it's going to be plus 82. And oxygen in the data booklet, that's 496. And minus 2 times N O coordinate bond. And you can take 496 to the other side and then divide the whole thing by minus 2. Okay, so if we do that, so it's going to be 82 minus 496 divided by minus 2. That gives me कितना आ रहा है? 207. ठीक है, remember the units, show the working properly. So 207 kilojoules per mole.
Sir,
That's the
in
next
bond
one.
frame, sir, इस bond formation में
क्या
मतलब
question?
do we जी question ये कि मतलब in exothermic reaction bond formation, right? Do we add the sign negative? So that negative adds with the negative of this formula, तो plus हो जाता है वो.
नहीं,
अगर
just नहीं वो बस नेगेटिव रहता है. ठीक है, you can either put negative over the whole thing और अंदर सारे प्लस कर दो.
अच्छा ठीक सही है.
बस
ठीक.
एंड गोल ये है कि उसकी वैल्यू नेगेटिव होनी चाहिए. That's it, because it's exothermic.
But it's supposed to be bond breaking minus. It cannot be added to it, right?
Yeah, but it could be. I mean, it's basically getting added bond breaking plus bond formation, right? Like in the bond formation values are all negative, so it
अच्छा
becomes all.
ठीक.
ठीक है. बस end result है कि वो values जो होंगी ना, they should come out to be negative. They should all be negative. They should not turn into plus. ठीक है. I said next one is that there's a thing called nitrocyl chloride, and it's a reactive gas that is sometimes formed when NO reacts with Cl2. So this is given, and you're given that NOCl is a strong electrophile. So ये alkenes का क्या reaction होता था? कि alkenes का जो reaction होता था, just a quick देख लेते हैं, just 1 second. Alkenes, they always have this reaction where the electrons are going to be attracted to the positive charge in the pi electron cloud, and the electrons over here are going to get repelled. ठीक है, the Cl wants to take away electrons. Electrons are going to come over here, and the electrons in this bond over here, they're going to get repelled. So this is the first step. ठीक है, इसके अंदर वो देख भी लेते हैं कि वो alkenes वाला हमारा किधर गया है. ठीक है, instead of me drawing the whole mechanism, सारे के सारे वो mechanisms देख लेते हैं. Just wait 1 second. और Markovnikov's rule, etc. everything. बल्कि यहाँ पे पहले draw ही कर लेते हैं. Next step would be that you would have a double bond, and there's going to be H, and there's going to be another H, or H and H. And what would happen is that it would form a carbocation. That one of the carbon would become positive, and this N and double bond O is going to react with it, and the Cl minus 1 would break off. And obviously, in the next step, the Cl minus 1, don't put it over here, the Cl minus 1 would come in, and it would then go and attach itself with the carbocation. That's the whole reaction mechanism, and you have to draw all the lone pairs. So this was Cl minus 1 with its lone pairs. You have to draw the curly arrows, you have to draw the structure of the intermediate, which we have drawn. So सारा का सारा draw हुआ है, ठीक है. और यहाँ पे ना we can just have a quick revision on क्या क्या था electrophilic addition. ठीक है, so just after this, this was your alkenes. All reactions would happen. So all reactions. 1 second. 1 second. अच्छा ये all reactions would happen with this double bond pi electron cloud, and every time what would happen is that whether it's bromination, the positive bromine is going to attract the electron cloud and bond with it, and the other carbon atom next door would become a carbocation, and the Br minus 1 would go and attach itself. And this would happen pretty much with all the electrophiles, uh, whether it's hydration of alkenes, phosphoric acid catalyst में water add हो रहा है, same thing would happen. The H plus 1 would get attracted, and then the water molecules would come and bond with the positive carbocation. And then you had the Markovnikov's rule in this, which was for unsymmetric alkenes. If you have an unsymmetric alkene and you get two different products, there would be a possibility that one of them would be your major product. And the reason for that was that the carbocation that was surrounded by more carbon chains, electron donating carbon chains, is going to be more stable because it would have a smaller positive charge, which is why it would allow the H to take away electrons. The carbocation that would be bonded with fewer carbon chains, it's going to be unstable because its positive charge is going to be much higher, which is why it won't allow the H plus 1 to take away the electron. So the intermediate carbocation would always be the stable carbocation. ठीक है, कहाँ पे this one? If there are two carbocations that are possible, the intermediate carbocation is going to be the most stable one, the one that is going to be surrounded, जिसका जो positive charge ना, that's surrounded by more carbon chains, that would be the one that's more likely to form. अच्छा बाकी किधर गया paper? अच्छा ये. Next question. You've got two elements. What is meant by the term relative formula mass? ठीक है, so it's a mass of a molecule basically, but compared to compared to 1/12 the mass of carbon 12 isotope. So compared to 1/12 the mass of carbon 12 isotope. Next one is F2 and HCl are both molecules, suggests why the boiling point of HCl is higher compared to F2. Now, the reason the boiling point of HCl is higher compared to a fluorine molecule, क्या reason होगी?
Sir, covalent bonding और वहाँ पे we have van der Waals forces.
कोवलेंट तो दोनों में है, यहाँ पे दिस इज पोलर, इट हैज
परमानेंट डाइपोल
Yes, हाँ.
इसमें permanent dipole interaction है. Why? Because Cl is more electronegative, so this is partial negative, this is partial positive. Van der Waals दोनों में है, ठीक है. Van der Waals are always present, but this one only has van der Waals forces. ठीक है. So you're going to talk about the intermolecular forces that HCl has permanent dipoles, which are much stronger compared to F2. Why does CaF2 has a higher boiling point? Now remember, it's an ionic lattice. Ionic lattice के अंदर they don't have intermolecular forces. It's a bunch of positive ions and negative ions. They're all connected to each other. So it's a giant ionic lattice. So you're going to talk about the giant ionic lattice. और इस lattice के अंदर there would be strong ionic bonds. ठीक है. Remember, intermolecular forces are only going to be present in simple molecules. Metals के अंदर intermolecular forces नहीं होती. Giant covalent structures, no intermolecular forces. Giant ionic lattices, no intermolecular forces. Next is CF2 can be made by the reaction of calcium carbonate with HF. Now we're going to assume that HF is like HCl. So what's going to be produced? He's already told us that CaF2 is produced. What else would be produced? There's going to be a water molecule. Okay, it's a carbonate plus acid reaction. Carbon dioxide and water are going to be produced in the reaction. You can balance this equation. The next one is chloride ion की write the electronic configuration. So that's 18 electrons. So it's going to be 2s2, 2p6. You're going to have 3s2 and then usually it's normally it's 3p5 for 17 electrons, but since it's 18 electrons, that's going to be 3p6. When Cl2 is passed over hot iron, FeCl3 is formed. So Cl2 passing over hot iron and FeCl3 is formed. That means Fe gets a charge of +3. But however, when I2 is passed over hot iron, the following reaction occurs. So when Fe is passed over, iodine is passed over hot iron, Fe plus 2 is only formed. State what you would observe during the reaction between Fe and I to explain why. So what's the observation, especially with iodine? And explain why FeI2 is formed rather than FeI3. So the first is that iodine is purple vapor, so purple vapor disappears. So the purple vapor over here, it's going to disappear. That's your observation. And why is Fe plus 3 not forming? Now, one thing you've studied in organic is that as you go down the group, you have Cl, you have bromine, you have iodine. As you go down the group, the tendency to gain electrons or get reduced, it decreases. So they become weaker oxidizing agents. Because smaller atoms, they like to gain electrons very strongly. They're more electronegative. So you have Cl. So Cl is pretty electronegative and likes to gain electrons. But when you move down the group, iodine has a lot of shells. The nucleus is surrounded by shells. It's completely covered by shells, very high shielding. So it doesn't really attract electrons that strongly. So basically what iodine is trying to do is trying to pull electrons away from Fe, right? And the same was being done by Cl. Cl was trying to pull electrons from Fe as well. Cl is more successful at that. Why? Because it's a good oxidizing agent. So Cl is a powerful oxidizing agent so it's able to extract electrons from other elements. But iodine is a weaker or relatively weaker oxidizing agent. It doesn't really like to gain electrons. So that's what's happening. Now the next part is FeI2 is soluble in water. Student carries out chemical test to confirm that a solution of FeI2 contains aqueous potassium iodide. The student adds a single reagent and a precipitate forms. Now for all these halides, the test is you add silver nitrate aqueous, and the result is going to be yellow precipitate. Why? Because silver nitrate contains Ag plus one ions, whatever FeI2 contains I minus one ions in solution, and they're going to combine together to form a precipitate of this insoluble AgI. So that's your ionic equation as well. Now, compounds containing I minus one are often contaminated by bromide. Identify a further reagent that student could use to show that the precipitate forms contains iodide ions. Now, the next part of the test is uh, the precipitate of AgBr, which is cream precipitate, it dissolves in concentrated ammonia, or you can say it's partially soluble. Whereas the precipitate of AgI is completely insoluble. So it's completely insoluble in excess ammonia. So the other reagent that you're going to use is ammonia. AgBr would dissolve, but AgI is not going to dissolve. So I think it's just one mark. You just have to identify ammonia as the reagent. Next is HOF is the only molecule that contains elements hydrogen, oxygen, and fluorine. Draw a dotted cross diagram. Now oxygen is going to be in the middle. Fluorine, oxygen forms two bonds. So there's going to be H, and there's going to be oxygen in the middle. Oxygen forms a bond over here and a bond over here, and four electrons would be remaining, and fluorine would have, we can change the symbol for fluorine, make shaded dots. That's it. I said then you have HOF can be made by the reaction of F2 with ice. The reaction is similar to the reaction of Cl2 with cold water. Suggests an equation for the reaction of F2 with ice. Now, he said that it's similar to the reaction with cold water. So basically, that's the reaction we're looking for. Now, what happens in the reaction with cold water? I mean, we need to know what happens with Cl2. If you add it to water, it forms two things. One is HCl, the other one is HOCl. So you're going to write the same reaction for fluorine. So it's going to be fluorine plus water, and it's going to produce HF. And the other thing that it's going to produce is HOF. Asaske बाद next one is HOF is an unstable compound, decomposes to form. So you have to figure out draw the. It's an exothermic reaction. So something like this. This would be HOF, and this over here would be HF plus. So that's the decomposition happening plus half O2. So plus half O2. Draw labeled, and it has to be labeled as well. So start labeling it. Two things. This is going to be the enthalpy change, delta H, and this over here from the reactants to the top. That's the activation energy. So those are the two labels that would be needed, and the arrow direction should be correct. Next is pure HF is a colorless liquid. The liquid contains HF molecules that have strong hydrogen bonds. Draw a labeled diagram to show those hydrogen bonds. Now, that's your HF molecule. Because it's a highly polar molecule, this is going to be partial negative, this is going to be partial positive. And the reason it's going to be even more partial negative is because F has these extra lone pairs. So draw another HF molecule which is going to be similar. You must show these lone pairs. So this is negative, this is positive, and they're going to attract each other very strongly. So the lone pairs of fluorine, because it's a smaller atom, they have very high charge density, which is why the negative charge is very concentrated. It's going to attract the positive charge. Again, the positive charge is highly concentrated. It has a high charge density because hydrogen atoms are very small. They're smallest. They're one of the smallest atoms. They are the smallest atoms. अच्छा उसके बाद क्या है कि you have interhalogen compounds such as BrCl or IF6, and they contain two or more different halogen atoms that are covalently bonded together. D is an interhalogen compound that contains only chlorine and fluorine. Now, we're not sure what the formula is. We don't know how many chlorines, we don't know how many fluorines. So that is what we're not sure of. Now you're given use the general gas equation to calculate the MR of T. So we've given a lot of things. So we can use PV is equal to nRT. That's pressure. That's 101325. The volume is 1 dm cube, but it should be in meter cube. To convert dm cube into meter cube, that's going to be 10 power minus 3. N is moles. That's mass, which is given 4.13. Divide that by the MR into R, which is 8.31, into temperature, which is 0 degrees centigrade. That's 273 kelvins. So we're going to try and find the MR. क्या value आ रही है? What's the MR coming out to be? अच्छा इसको जल्दी से कर लेंगे. It's ये क्या बन जाएगा? 101. नहीं sorry. It's going to be ठीक है 101325 into 0.001, and that
So
comes
92.5.
ठीक है 92 point. That comes out to be 92.5. अब फिर वो कह रहा है use your answer to determine the molecular formula of D. अब it's coming out to be 9. If you're unable to calculate the MR, so now you have to figure out the molecular formula of D. तो कितने Cl होंगे, कितने F होंगे? Now Cl is 35.5 and F is 19. तो मुझे था कि what combination would give you 92.5? Can anyone work this out? I'm pretty sure there's going to be just one Cl. Why? क्योंकि 0.5 आ रहा है. ठीक है. So there should be an odd number of Cls. Can't be 3 Cls क्योंकि if you have 3 Cls तो value उससे ज़्यादा हो जाएगी, 105 हो जाएगी. So probably just one Cl.
Sorry, 1 Cl और 3 fluorine.
ठीक है, तो साथ ना उसके 3 fluorines होंगे. ठीक है, that's it. So it's going to be ClF3. अच्छा एक और चीज़ भी याद रखना कि Cl can make more than one bond. F cannot. ठीक है, तो F cannot expand its octet. Cl का जो outer shell है ना, I mean if something has, अगर कोई भी चीज़ second shell तक है ना, remember that. Although this is not related to the question, that can have a maximum of 8 electrons in its outer shell. ठीक है, that's it. So fluorine cannot have more than 8 electrons. Fluorine की जो oxidation state होगी ना, वो सिर्फ एक ही होगी. But it's capable of forming just one bond because it needs just one electron. लेकिन Cl is in the third shell. ठीक है, now remember Cl has 7 electrons, so it can have 8 electrons, but it can have a maximum of 18 electrons. So Cl जो है ना, that can make a lot more bonds. It has a much bigger shell. So remember this, third shell onwards ना, third shell के जो elements होते हैं, and after that Cl हो गया, iodine हो गया, they can make a lot more than one bond because they have a lot more electrons that could be added into this shell. As a question number 3, we're going to come to, okay, a student carries out several tests to distinguish between PQ and R, so it's a test for sodium. अच्छा कौन react करता है sodium के साथ? Remember sodium carboxylic acids react with sodiums. There is no carboxylic acid. The other thing that reacts with sodium is an alcohol. Alcohols react with sodium. And how do they react? If you have an alcohol, the alcohols they lose the H at the end. So they become the H is lost and takes its place and H2 gas is produced. So it's like a metal plus acid reaction. So P is going to react, and I don't think Q and R are going to react with sodium. So no reaction with either Q और R. ठीक है, उनके साथ रिएक्शन जो है वो नहीं होगा. अच्छा खैर, उसके बाद अब कहानी क्या है कि उसके बाद वो कह रहे हैं कि 2,4-D NPH. Now 2,4-D NPH is a test for identifying what? It's a test for identifying aldehydes and ketones. So ketone here and an aldehyde over here. ठीक है, और 2,4-D NPH के बारे में सारी चीजें पता होनी चाहिए. किधर है हमारा? ठीक है, उसका जल्दी से हम स्ट्रक्चर वगैरह भी देख लेते हैं कि aldehydes and ketones, you should remember the structure of 2,4-D NPH, 2,4-dinitrophenyl hydrazine. तो probably पता नहीं है कि नहीं है इसमें. This is 2,4-D NPH. ठीक है, remember this molecule over here, benzene with two NO2s and NH2 दोनों sides पे. This is a hydrazine part. ये react करता है. It's a condensation reaction. C double bond O carbonyl groups के साथ ये react करता है, and the oxygen and the H are lost. They form water, and the two they bond together, form a double bond. This is the yellow precipitate that's formed with 2,4-D NPH. ठीक है, orange precipitate, sorry. That is the precipitate that's formed. And the last one would also, because it's an aldehyde, that would also do the same. And then you have acidified K2Cr2O7. That's an oxidizing agent. So Q or R not going to get oxidized. Ketones are not, they don't get oxidized. Aldehydes, they do get oxidized. So K2Cr27, it's going to be orange to green. And over here, you're not going to have a reaction. ठीक है.
So in the upper portion where आपने sodium में tick लगा, उसमें भी we have to write observations.
अच्छा हाँ ठीक है. तो क्या ऑब्जर्वेशन होगी? हाइड्रोजन गैस बबल्स, एफर्वेसेंस, ठीक है, मतलब H2 गैस लिखने की जरूरत नहीं है, बट यू गोइंग टू सी बबल्स. अच्छा, नेक्स्ट वन इज ये ऑक्सीडेशन रिडक्शन. हम सारा पहले गो थ्रू भी कर लेते हैं क्योंकि आगे उसी का आ रहा है. किधर है वो हमारा अल्कोहल्स. अच्छा, remember alcohols, primary alcohol to aldehyde to carboxylic acid. Primary alcohol to aldehyde, that's K2Cr27 or KMNO4 and reflux. If you want to stop at aldehyde, you would need to distill it, not use reflux. ठीक है, ताकि ये evaporate हो जाए and you can condense it. Aldehyde to carboxylic acid, you can use K2Cr27 or KMNO4. You can also use toluenes or Felling. ठीक है, and secondary alcohols can turn into ketones by KMNO4 and K2Cr27, but secondary alcohols, ketones are not, they don't get oxidized. और फिर tertiary alcohols की कोई oxidation नहीं होती. And then you have reduction. That's the opposite. Carboxylic acid से वापस aldehyde पे जाना ना, that's LiAlH4. This is very specific, LiAlH4. But from aldehyde to alcohol, it's NaBH4 or LiLH4. You could use both reducing agents, or you could also use nickel plus H2 at 150 degrees centigrade. Ketone से वापस जाना है तो it's also NaBH4 or LiLH4. So that's the reduction that you should know of. तो अब वापस आ जाते हैं क्वेश्चन के ऊपर कि write in the equation for the reaction of Q with NaBH4. तो Q क्या है? किस पे चेंज हो जाएगा? It would turn back into an alcohol, so it's going to be CH3. It's going to be COH and H, and there's going to be CH2 and CH2 and CH3. यानी at the end of the day क्या हुआ है? 2 hydrogens got added, but you don't even have to count the molecular formula. 2 hydrogens got added, this one and this one. So you're just going to add the 2 hydrogens. So 2 hydrogens are going to get added, and it would become C5H12 and O. Okay, so that's the equation. फिर अगला question, R exists as a pair of stereoisomers. Identify the type of stereoisomerism and draw the structure of the other isomer. Type of stereoisomers and draw the structure of the other stereoisomer. तो R किधर है भाई? This is R. ये देख के कौन सा isomer है?
Geometrical.
ठीक है, that's a geometric. Don't write cis trans. ठीक है, cis trans उनके individual नाम होते हैं. ठीक है, always call it a geometric isomer. And the other one would be कि एक साइड को flip कर दो. ठीक है, CHO. So the other isomer is going to be कि H ऊपर नहीं. I'm going to flip this side. So I'm going to put CH2. CH3 would be pointing upwards and the H would be pointing downwards. Why do they form stereoisomers? Because there's a pi bond over here. और pi bond की वजह से rotation is not possible. I mean the 2 carbon atoms are fixed in position. अच्छा, फिर ये आपके पास infrared spectrum दिया हुआ है PQ and R, and this is the IR spectrum. Open the data booklet as well. For the IR spectrum. अच्छा, ये infrared आ गया, and strong peaks, weak peaks, etc. So have a look at the infrared spectrum over here. You can see an absorption. This is above 3200, right? So something's appearing above 3200. So what does the table show over here? Above 3200, it's either an amine. We don't have an N, so that's out of the question. So that's gone, right? So you can get rid of this. The other thing is the only thing left is an alcohol, and it's not a carboxylic acid because that range is not there. So it's either one of the 2 alcohols. So an alcohol is confirmed, and that would leave you with which one? There's only one with an alcohol, so it's P. It's going to be P. That's the one that's with the alcohol. तो alcohol वाला pick कर लो, ठीक है? और वो बता दो कि भी 3200 से ऊपर ना there was this. So the compound is P. अच्छा, what other explanations do you have or can give? कि वो फिर से जाके P देखना पड़ेगा. Apart from that, I don't think you need to. कितने marks हैं? Apart from that, I don't think you should be giving any more. क्योंकि आंसर तो आ गया. You can look at other bonds, C triple bond N. वो जाके देख लो कि is there a C triple bond N? हाँ ठीक है, there's an absorption at 2200 to 2250 for a C triple bond N. So you can talk about that because you are getting an absorption at this 2200 range. So you can talk about the C triple bond N. You can talk about that. So that's another one you could come up with. अच्छा, उसके बाद there's this molecule, allyl. Give the systematic name of this molecule. So what would you call this molecule? It's 3 carbon atoms. That's 1, 2, 3. So it's definitely prop. Okay, that's prop. And the double bond is at position number 1. So it's prop 1-ene. And it's 3 chloro. Remember, chloro has to be given the least importance. Okay, it's not that important. Double bonds are more important compared to alkyl chains or these halogens. Now there's this molecule, this reaction happening, and you can see that this carbon had hydrogens. Now it has a Cl attached. So this is a UV light reaction. It's a free radical substitution reaction. In the first step, Cl radicals are produced. Why are they produced? Because the Cl molecule it splits into 2. homolytic fission happens, and the Cl radicals are formed. Next part is that propenyl radical is formed in the first propagation step of the reaction. Write an equation to show the formation. So how is this radical produced? You have CH2, double bond, CH and CH3, this molecule. A Cl radical comes in and it steals one of the hydrogens over here to form HCl. So what's going to be left is going to be CH2, and there's going to be double bond, and then there's going to be CH, and then there's going to be another CH2, and this carbon is going to be your radical. So that's your HCl molecule that's being produced. I said next one is explain why the free radical substitution reaction gives a low yield of allyl chloride. So why does it give a low yield? कौन बताएगा इसका क्या आंसर है? Why are we getting a low yield? Ibrar, Rida, why are we getting a low yield in this case?
So maybe because of वो major and minor.
नहीं उसका मेजर माइनर का नहीं, उसमें लो यील्ड इसलिए कि Cl radical can come in and it could take away any of the hydrogens. ठीक है, that's the reason why it's a low yield. क्योंकि कोई भी जा सकता है, ठीक है. It's an uncontrolled reaction. Any of the H atoms could be substituted. So you're going to get different products. And it would result in many different products. कहीं पे एक Cl सब्स्टिट्यूट हुआ होगा, कहीं पे दो Cl, कहीं पे उससे ज्यादा, resulting in many different products. ठीक है. और फिर ये कि allyl chlorides can also be formed by the following substitution reaction. Suggest the identity of the reagent X. तो OH को substitute करना है Cl से. This is going to be PCl3 plus heat. बल्कि उसने सिर्फ reagent पूछा है, conditions नहीं पूछी. SOCl2 भी हो सकता है. It could be PCl5 as well. So the OH is going to be substituted by Cl. फिर अगला क्या है? Series of reactions starting from allyl chlorides is shown. तो suggest a reagent that can be used in reaction 1. तो यहाँ पे क्या हो रहा है? यहाँ पे diols बन रहे हैं. How do you form an alkene turning into a diol? That's cold dilute KMnO4. That's mild oxidation. ठीक है, an alkene would turn into a diol. फिर वो कह रहे हैं reaction 2, the organic product of reaction 1 is mixed with concentrated sulfuric acid and an organic acid and then heated. So ये clearly it's an ester that's forming. What's happening is कि you're bringing in ethanoic acid और इसका OH और इसका H बीच में से निकल जाएंगे and they would form this ester. दो O आ गए, ठीक है. So the reagent is ethanoic acid. State the role of sulfuric acid. That's role of sulfuric acid is a catalyst. And the organic acid is ethanoic acid, CH3COOH. Okay, state the name of the mechanism that occurred in reaction number 3. कहाँ पे 3? ये वो nucleophilic addition है. नहीं, it's not nucleophilic substitution है. So that's nucleophilic substitution that's happening. Okay, Cl जो है, this carbon is positive और उसकी जगह ना CN आ गया। ठीक है, that's nucleophilic substitution that's taking place over here. अच्छा, फिर उसके बाद ये कि उसके बाद क्या है कि the organic product of 3 is Y. Y can be hydrolyzed using H2SO4 to form Z. The molecular formula of Z is C4H8. तो क्या है, organic product of reaction number 3 is Y, जो कि दिया हुआ है. Now Y is being heated with sulfuric acid to form Z, and the molecular formula of Z is given. अब हाइड्रोलिसिस होगा अगर वो एसिड के साथ हीट कर रहा है ना, so hydrolysis would happen. तो सबसे पहली चीज है कि CN would change into a carboxylic acid, हाइड्रोलाइज हो जाएगा. ठीक है, so this CN would be gone and it would instead turn into a carboxylic acid. और फिर ये एस्टर्स का भी हाइड्रोलिसिस होता है. ये एथेनोइक एसिड जो जुड़ा हुआ था ना, वो वापस अलग हो जाएगा. So it's going to be these 3 carbon atoms. ये फिर लास्ट वाला जो है ना CN, ये कार्बोक्सिलिक एसिड में चेंज हो गया, और यहाँ पे आई थिंक इट शुड बी एन OH एंड दिस शुड also be an OH. तो आपके 4 ऑक्सीजन पूरे हो गए. तो the ester would break again, hydrolyze हो जाएगा, and the CN would turn into a carboxylic acid back again. तो आपके पास क्या आ रहा है कि पिछला पार्ट, draw the structure of Z. So we're done with the structure of Z. तला इब्रार, ये क्लियर है?
Yes, sir.
जी सर. सर ये एस्टर की हाइड्रोलिसिस भी हो रही है इनटू एन हाइड्रो. अच्छा ठीक है सही.
ठीक है. हाँ, एस्टर भी तो हाइड्रोलाइज होता है ना.
ठीक है.
अच्छा चलो फिर नेक्स्ट वन. ज़ेब, इसके बाद वो वाला कर लेंगे आपके क्वेश्चंस. ठीक है. ये वाला है कि you're given this reaction and 2-bromo 1-chloropropane is the major product of the reaction. Explain why 2-bromo 1-chloropropane is the major product of the reaction. ये वो आ गया उसका alkenes का. It's an unsymmetric alkene. ठीक है, मतलब ये Cl लगा हुआ है यहाँ पे, there's H and there's H and 2 H's over here. तो HBr add हो रहा है. So where does the H get added to? The H will get added to which part? It would be added to this carbon atom. And this would become the carbocation. बीच में डबल बॉन्ड खत्म हो जाएगा. और अगले स्टेप में the Br would come in. ठीक है, it's going to come in. So why is this carbocation formed? Why is the H not getting bonded to this one? तो उसके बाद आप बताओगे कि the secondary carbocation is more stable. I said it's more stable. More alkyl donating, more alkyl chains. So more electron donating effect. So there's more electron donating effect, which makes it more stable. ठीक है, that's what you're going to write over here. ठीक है, इसके बारे में बताओगे कि जो secondary carbocation है, that's more stable. Markovnikov's rule का हमने पहले भी डिस्कस किया था. And that I think sums up the paper. ठीक है. Zeib, are you there?
Yes, sir.
अच्छा एक सेकंड देना, मैं वो किधर भेजे थे क्वेश्चन? एक सेकंड मैं
WhatsApp.
क्वेश्चन. हाँ ठीक है, एक सेकंड मैं क्वेश्चंस खोल लूँ. अच्छा इसमें भाई भाई जल्दी से मुझे डिस्कस करते हो कि कौन कौन से क्वेश्चंस में प्रॉब्लम है.
Sir, the part where they're saying the name, the type of reaction.
किस में इसमें कौन सा पार्ट.
Yes, the name, the type of reaction occurring
अच्छा
between.
ये remember ये hydrolysis है. It's all these reactions with chlorides of with water, that's hydrolysis. ठीक है. That's hydrolysis. Not all of them get hydrolyzed. NaCl का hydrolysis नहीं होता. It only dissolves. MgCl2 mostly dissolved, very slight hydrolysis. उसके बाद फिर hydrolysis शुरू हो जाता है. AlCl3, SiCl4, strong hydrolysis. uh, Phosphorus chloride, even stronger hydrolysis, etc. So on. ठीक है. तो remember it's hydrolysis. फिर और कौन सा.
This whole question
ये कौन सा part.
is the part of this same very question.
अच्छा बस एक मिनट रुकना आसान हो जाए. अच्छा चलो ये जहीब.
Yes, sir.